2 of 11B data distributions. Warm-ups here. How can you interpret the distribution of data in the data set? It's skewed left or right or symmetrically distributed. We can analyze what that means as far as the relationship between the mean and the standard deviation for symmetric ones, and the median and the interquartile range. We can use those to determine center and spread for skewed distributions. I want you to look at a data set, this problem. A data set has a mean that is approximately equal to the median. Mean and median about equal. Ralph says the median should be used to describe the measure of center and the measure of spread. What was the error here? So think about the description. If median and median are about the same, median and mean, median is about the same as the mean, then we know it's somewhat symmetric or symmetrical. And then remember, when it's symmetrical, we use standard deviation. So symmetrical, standard deviation go together along, well, if the mean and median are the same, it doesn't really matter, right? But technically we use the mean. Let's look at this picture. Explain how to determine if the data distribution shown is skewed left, right, or symmetrical. So if I drew a line kind of following the curve here, I can call this my tail, and it's pulling the mean away from the median, right? So this would be skewed, it's pulling it to the left, so it's skewed left. Today we're going to look at a normal distribution. If we think in different examples, if we think about this situation, we're going to take the heights of all the people in a large group. So not just a little small group, but a large group of people. You could have some data results that look something like this. The number of people, this says height down here, by the way, it kind of got cut off. So the height, the number of people that were around 65, 66, 67, 68 or so inches was more than any other one. And then it kind of goes down on each side. We have a few outliers here and here. But more or less, it does look like a normal distribution where the mean, the median, and the mode would be about the same. This is called a bell-shaped curve at times, but here's another word. We talked about this previously, but it's called a normal distribution. And the curve is called a normal curve. And this can be found, it's called normal because there are many, many real-world situations where this happens. And we get a lot of the data, it's symmetrical, and most of it's clustered near the mean. And the heights of people in a large group, a large enough group, are likely to be normally distributed. Now, in a real-world situation, kind of like we had here, you notice it doesn't perfectly fit the model, and that's because it's real-world information, right? We're going to have what we call outliers or something that just doesn't quite fit the rest of it. Here's another situation. The probability of landing on each of 8 equal parts of a spinner. So I'm going to actually spin a spinner a number of times and write down how many times it lands on each number. And here's what I got. So I did spin it a lot of times, right? Over 100 times probably. And this is what happened. I got 3 about 7 times, got 4 about 16 times. So, but overall, if you looked at that data, I mean, you wouldn't even really be able to draw a curve. Kind of, maybe even a little, right? It's about the same. And I would say if you only did the spinner, you only spun it 100 times, to get a better distribution, you probably should spin it about 500 times and see if that changes the shape of the graph. But it's definitely not normally distributed because honestly, the outcome should be about the same. The probability of each one occurring should be about the same. It's not exactly from this. What about the scores on an essay test? Oh, sorry, I read that wrong. An easy test. An easy test. So your teacher gave you an easy test. That was nice of her. Look what happens. This is what my data looked like. So I like to kind of draw that line on top of it. Now again, the tail's headed to the left. So this is skewed left data. Median would be over here somewhere. Hard to tell exactly where. And the mean would be over here somewhere. Whoops. The mean, because the tail pulls the mean away from the median. The scores on an easy test are often skewed to the left and not normally distributed because more students would receive higher scores. Here's another example. The number of children in a family. What do you think about this? The number of children in a family, it's definitely not normally distributed, right? There's the graph we have. Just think about it. So these people that were surveyed, most of them didn't have any. And then it got smaller and smaller and smaller as the numbers get higher and higher and higher. So that is definitely skewed to the right. I want you to try this one. Think about you're finding the weight of individuals in a population. So maybe you had the whole school enter their on a Google form of some sort or something. Everybody entered their weight. Do you think this would be normally distributed? I think it probably would be, because there would be some that would weigh less, and that might differ. As you get older, you tend to weigh a little more, right? Because you're growing still. So that could be another situation. How about the scores on a difficult test? Now, if it was difficult, if it was really difficult, like some of my professors in college like to do to us, I would guess it might look more like this with it skewed to the right. And this to the right means positively, just something else to put in your vocabulary. Skewed to the right means positively because it's going in a positive direction. Let's look at this data set. So when I look at this data here, and I'm going to make my histogram, it looks like this. And what my microphone was kind of going in and out. So what it's telling me here is that, notice this is like 10, interval of 10 between all these. And this is what I was saying before. You can change that if you want to, and you might need to, depending upon your data and trying to get how it's distributed. But this looks kind of like this, right? So it's skewed to the left. It's going to the negative. The tail is pulling it. So the mean would be over here somewhere, and the median would be here. So the tail pulls the mean away from the median. I'm going to show you how to use this TI-84 to do this. So I'm going to get out of here for just a second and show you how to make a histogram on a TI-84. Do you want to keep my annotations so far? Yes. So let's go over, I'll just start a new tab here. And if you don't know already, you can do this MCA calculator. Gives you a TI-84 plus CE. It's a pretty nice little calculator. And you look for the standalone calculator. It does time out because it's like you're doing a practice test. So it does time out after a while. I might have a few too many tabs open right now for it to be very happy with me. You don't have this much problem finding it. There we go. It's loading it. And then you just sign in as a guest is what you sign in as. It just signs in for you and hit the start button. And then it'll give you a little calculator up here in just a minute. And that's the grapher that we're going to use. So you can stop and fast forward if you already know how to do this. If you already know how to enter the data, that's fine. But in case you forgot, here you hit your stat button and then you hit edit because we're going to make a new list. I don't know, I don't have anything in here. So I'm going to type them in on my computer to make it a little faster. 64 and hit the enter, and then 72. I had them in order, so it makes it a little easier. I have to do, first of all, you could just go to second, oops, never mind. You could just go to Zoom 9 and see if it works. Okay, well, that's not real helpful, is it? What if I hit a graph? Okay, so I don't have something set up. So I need to make sure my stat plot is set up. So let's go to second y equals my stat plot. Oh, it's turned off. On my calculator that I use regularly, it's turned on. So I want to hit the enter there. And I'm going to do a histogram. So, I do want it flashing. So yes, I do want it on. Otherwise, it doesn't know what to do, right? There's the histogram. It also has, you can see the box and whisker plots too. So enter that. Notice it goes down to one list here. It's only going to take data from one list and make the histogram. Now it's going to decide, if you want to look at the graph, you can do this. Oops. Zoom 9 stat. There we go. Okay, it's going to decide how far apart these are. If you want to change that, then you go to your window and maybe you want every 10 you want it to make a little group. You can just change that to 10. You can also change your X and Y values too. Let's go back. Okay, so I like that, all right. So let's do the Zoom 9 again. So if you're happy with that, again, what do you think? Do you like the way it is or not? That's up to you. I thought this graph does the same thing. Okay. All right, so that gives you an idea of the histogram. Now, I copied and pasted this histogram. So it looks like those numbers are a little different, right? So the data distribution looks a little different. All right, let's go ahead and start from our current slide. So we made our histogram, and I did show you how to make it on the 84. You can also just Google. That's a good way and positive way to use Google. So then we're going to analyze the shape, and we can see that we have more data bunched over here to the right. So that means the tail is pulling the mean over to the left. So it's skewed left. If you look at, since it's skewed, we'll use the median and the interquartile range. And I was drawing on this earlier, so you can see I counted the number of data points. 1, 2, 3, 4, 5, 6, 7, and 10, 14. There were 15 of them. So, and that's also something that comes up on your calculator stats, by the way. So this one is in the middle. That's my median because it's in the middle. And then the first quartile, again, I take whatever's to the left of that median and divide that in half. And this one is in the middle there. So that's my first quartile. And then on the right, this is the third quartile. And you might want to look at the interquartile range. Remember, that's from third to first quartile. And you could also look at how far is the third quartile from the median. So this is 17. And then the first quartile from the median is 22. So there's a little bit of difference there, and that lets you know that it's skewed. That's how you know that it's skewed. Again, if you look at on the TI 84 plus CE, it puts these 5 numbers in order. So you can do an analysis that way and get the same information. So the distribution is skewed left with a median at 98 and the interquartile range of 39. And these are numbers that are helpful for analyzing the data. Remember, if median and mean are equal or very close, then the data are likely to be symmetric. I want you to try these. Go back if you're not sure which buttons to push on your calculator. Go back and look or Google a video on how to do it. But the important ones are setting your stat plot. So that's second y equals. You want to make sure you have that on. And then changing your window if you need to look at the distribution in different ways. So when I did this, this is what I got. But then I did it again because it seemed a little, this one just seemed a little clunky to me. So I thought I'm going to change. What I changed was my X scale, how wide those little things are apart. This one was 3 and this one was 2. So I have more groups over here because my grouping was smaller. And then I take a look at numbers. Here I have a mean of 18, standard deviation of 3.6. Then I look down here and I have my median of 18. Well, even though this doesn't look perfectly normal, and this one definitely doesn't. This one looks skewed, doesn't it? But when I pulled the first one, it looks skewed. But when I did this one, I could kind of see that it could be close to normal. But the reason I'm making that conclusion is that the mean and the median are exactly the same. And then I look at the difference between the quartile and the median here. What would you say? 18 minus 5.5 is about 2.5. And if I add 2.5 to this, the third quartile is actually about the same too. So that kind of tells me that it probably is normally distributed. And then I would use, since mean and median are the same, I would use mean and standard deviation when I did a final analysis of the data. Here's a box plot, and this is just another example. Notice you can kind of tell from the box plot, it has a long tail over here, that it's going to be skewed to the left. And that's negative direction. So the distribution is stretched much farther in the negative direction than the positive. That kind of helps. Negative meaning to the left. Here's some summary concepts for you. So if you're looking at the shape of a distribution, if they're approximately normal, you use the mean and standard deviation for measures of a center and spread. For skewed, Use median and the quartiles information to describe the data. This was a normal distribution or symmetrical, and these are skewed left. The tail's pulling the mean to the left, and this is skewed right. It's pulling the mean to the right. That's all that you need to complete 11.3b Math Excel. I hope you find some of this interesting. I think it'd be more interesting if you could see how it's all applied, but we're just kind of skimming the surface on statistics. So we'll get into some more detail later on. If you're really interested in finding more out about how to use this kind of information, I would suggest signing up for AP Stats in next year or the year after that.